In the last video clip, we looked at how to do the planning for this investigation, where we are changing the amount of hydrochloric acid to see how that affects the rate of reaction between the hydrochloric acid and magnesium ribbon. So we filled in the planning sheet and we identified the independent, dependent and control variables. What we're going to do in this video clip, or what you're going to do as you follow along with me, is improve the method. So we're going to expand on the method using some of the ideas that we put in here about the control variables. So you'll need to flip between your control variables and your method, which you can find down further. So we're going to add some of that information in to make the method more valid and to make the method much more detailed, which can get you a much higher mark if you do it correctly. So that's what we're aiming for, to get as high a mark as we possibly can. So we're going to have a look through the steps. We'll start here. So we've got here, collect 3 test tubes of the same size. So that is a control variable that's been added in there. A test tube rack, detergent, hydrochloric acid, magnesium ribbon, a small measuring cylinder, a stopwatch, 250ml beaker and a thermometer. Alright, step 2 says make a water bath using the beaker and using cold tap water. Get the water bath to 20 degrees Celsius. Now this is one of the control variables that we talked about up here, where we talked about temperature. So we said how we're going to keep the temperature the same. We're going to use a water bath using a cold tap and beaker and a thermometer to keep the temperature at 20 degrees Celsius. So what we're going to add to our method is why we're doing that. So we'll take this information here that we wrote earlier. So if you're handwriting this, then you might like to draw an arrow off your method, or you might like to rewrite your method and add these steps in. So you can pause the video to do that, or if you typed this stuff earlier, because you're using a digital version, then you can copy and paste it. So we'll copy that, and you probably want to do it in a different colour so that you know what you're doing. So draw an arrow off here, or you can just add the information in or handwrite it out. So we're going to say why we're doing this. So this is the reason why we're doing this. So we're making a water bath using a beaker and cold tap water, and we're keeping it at 20 degrees Celsius because temperature affects reaction rate. We know that from a previous experiment. Higher temperatures can cause reactions to happen faster because higher temperatures give particles more energy to move around faster and collide with other particles faster. Okay, then we've got here another control variable that we added in before, so marking the test tube at 7 centimeters with a vivid. We need to add in here how we're actually doing that. So if we look back up at our control variable, we put the finish line on the test tubes for the bubbles. We will mark the line using a vivid and a ruler from the base of the test tube to 7 centimeters high. And then we also said why we'll do that. So for this one we're going to copy both those bits, because in the method currently it only says what we're doing, it doesn't say how or why. So we need to add the how and the why. Whereas before it already had the how, it says about using a water bath and how to make that water bath, but it didn't say why. So now we've got to add the how and the why. So we'll copy that again. You might want to draw an arrow off and pause the video to write this part in, or you can just copy and paste it and add it in. So we will mark the line using a vivid, and we'll just make it a bit more specific. So we'll say and measuring using a ruler from the base of the test tube to 7 centimeters high up the test tube. And then we've got the why we're doing this. So we must do this and keep the finish line the same so that it is a fair test. Okay, next step, we measure out 5 ml of hydrochloric acid into each test tube. Again here, we haven't said how we're going to measure out the hydrochloric acid. So if we look back up here at our... actually, we don't need to do that for that one, because that is our independent variable. But we need to say how we're going to use that. So we're measuring using a measuring cylinder. So in here, you might like to add, draw an arrow if you need to, measure 5 ml of hydrochloric acid using a measuring cylinder. so we're using a measuring cylinder, and we wrote in here that we will avoid parallax error, which is when you look up or down at a volume in a measuring cylinder and it changes the size of it. So we will avoid parallax error by reading the measuring cylinder, looking at it at eye level at the base of the meniscus. So we're going to add this in. So again, arrow out or copy and paste. We will avoid parallax error by reading the measuring cylinder, looking at eye level at the base of the meniscus. And then we'll add in a step then for the HCl into each test tube. Okay. So that's put in how we're going to do that. So we've said how we're going to make it more accurate. Okay, now we're back to looking at control variables. So we've got here, count 5 drops of detergent into each test tube. So we need to say why for this one. We've said how we're going to do it. We're going to have 5 drops of detergent into each test tube, but we need to say why. So we look back at control variables. The part that we wrote in red is because if we use more or less detergent, we will get more or less bubbles. Obviously that's not a fair test if we do that. So we'll say we must count the amount of detergent because if we see what we've got here. There we go. Because if we use more or less detergent, we will get more or less bubbles. Make it all the same colour. There we go. Okay, now this step here has already been accounted for earlier on. So we say place the test tubes into the water bath beaker. And then we've said place a 2 cm strip of magnesium ribbon into each test tube and start the timer. So we had something up here about the magnesium ribbon. We've said we need to use 2 cm size pieces because if we have more or less, we will get less reactions or more reactions, and therefore it won't be a fair test. So again, that's the Y. We need to copy the Y and take it down and stick it in there also. We must keep the same amount of ribbon each time because if we have less magnesium we will get less reactions and more magnesium will cause more reactions. Okay, so that's the Y there in red. Okay, this one here, stop the time when the bubble column passes the 7 cm mark. Well, that one's already been accounted for, so that's fine. We talked about that one up here in step 3, so we've said how and why we're doing that there, so we don't need to do that again. We're saying that we're going to record the times in the data tables. We're going to repeat the above steps for another value of hydrochloric acid, and we're going to record those again. We're saying that we're going to calculate the mean and complete the graph. So saying that we're calculating the mean shows that we're going to be averaging. So that's showing how we're going to keep this experiment accurate. And we should probably put something in here about the fact that we're doing each thing 3 times. So if we have a look back up here, it says collect 3 test tubes. So that tells us that we're doing the experiment 3 times. And here it says marking all the test tubes and putting detergent into all the test tubes and then placing the test tubes into the water bath beaker. So we might put here place all 3 of the test tubes into the water bath beaker, and then we might just put here in blue we are repeating this experiment 3 times for each value of HCl. Okay, so that just shows whoever is looking at your assessment that you know that you are repeating your experiment 3 times. Okay. So if you need to make those changes, you probably want to just pause the video while it's sitting on those stages so that you can copy them in. So pause here if you need to. Pause here if you need to. And then pause here